What you're looking at is the Global Ecosystems Atlas proof of concept dataset. Each pixel on this map is intended to represent the distribution of 110 of the world's ecosystems in a single map to support a range of different monitoring initiatives. It's a 110 class global map as the starting point for the Global Ecosystems Atlas. This map is supported by a range of ways of accessing it, which we can use for analysing ecosystem extent, ecosystem accounts, a range of other different underlying metrics that we're trying to monitor the planet. The thing I want you to notice about this map is the large areas of grey. The areas of grey on this map are places where we have not yet been able to bring any data about ecosystems into the Global Ecosystems Atlas. Many of these places demand new maps of ecosystems that have been built from scratch. And that's what I'm going to talk about today. I'm going to talk about how we're trying to address the challenge of putting places like this on the map with new ecosystem maps. And I'll try to do it in a way that takes you on the journey of what we're actually doing in being able to do this. So this is a generalized mapping workflow for supervised classification of land cover, where our main aim here is to map 110 different classes of ecosystems. And I'm going to walk you through this and explain how we're going to do it. And in particular, I'm going to focus on how Alpha Earth Foundations is helping us speed up this modeling component 10, 15, 20, 30 times faster than we used to do when we do our Landsat or Sentinel-based models by themselves. To support this mapping activity, the GeoAtlas project is building a brand new training data set of the world's ecosystems. These are 92,000 records of 110 different ecosystem types, which can underpin a range of different classification models whose task is to estimate the complete distribution of those ecosystems around the world. And this task is being led out of my lab in Australia, in North Australia at James Cook University. And I have a team based in Australia who's systematically working through those 90,000 records, consulting with experts around the world to annotate all of those pixels to one of those 110 ecosystem types. And this is, like my team, when they talk about this work, it sounds really boring. 92,000 points. You just go one after another for years, basically. But they were telling me the other day that they consider themselves digital explorers, And if you like to sit in an aeroplane and look outside the aeroplane, this is what we do every single day in my research lab. We look outside the aeroplane via a computer screen and we imagine what's down on the Earth's surface. And I'll take you through a couple of the things that we've discovered while we're doing this. This in South Africa, not South Africa, Saudi Arabia. Our team is looking for the actual type of ecosystem that these features represent. Later on in the show, I'll share you an Instagram post. Once a week we post these now because we're discovering these amazing patterns on Earth. Here's another one. Yemen, T7.4, according to the Global Ecosystem Typology. It's an urban industrial ecosystem on a sandy shoreline. Freeze-thaw lakes in the Arctic, absolutely incredible. And our team is looking at time series to understand the freeze-thaw dynamics when they're interpreting these 90,000 samples. Hyper-arid deserts in Saudi Arabia, absolutely beautiful. And here we are in the UAE today. Lastly, we're going to all corners of the world to achieve this. So we're looking to build a complete coverage global map of 110 ecosystem types, as I said before. So I want to show you an example of what we do with that data. Once we've got those occurrence records of those ecosystems, how do we actually turn it into maps that can be analysed to understand ecosystem distributions and extent accounts and change? And here's an example from one of the Atlas accelerator countries in the Maldives. What you're looking at here is a single island with a range of different ecosystem types on it. And the task of our mapping workflows and our modelling team, which is led by Alice Young, who Rebecca introduced before, and she's out the back if you want to talk to her. The task of the models that we're developing is to estimate the distribution of each ecosystem in a given place using that set of occurrence records. And the models that we've been developing over the last, 7 or 8 years in the Global Ecology Lab at JCU and at the University of Melbourne and Deakin University is to estimate the likelihood of occurrence of each one of those 110 ecosystems. So what you're looking at now is the probability that a pixel in this map is in an urban and industrial ecosystem. That's this one here. Secondly, we do that for all of the different potential ecosystems in that region, and we identify the pixels, the ecosystem types that have the maximum probability per pixel, and we can then turn that into a classified map. And what this classified map is a prototype map of the distribution of all of the ecosystems in this island. Now, that's how we're doing it from the top down, but that's not the right way to build ecosystem maps for all of the world. A much more appropriate way of building maps for the entire world is to support different users, different countries, different people to develop maps of their own local environment. And what you're looking at here is a workshop that we ran in Indonesia earlier this year. We're working with the Indonesian government to help them develop maps and help even the ecologists at universities and researchers to develop maps of ecosystems as well, that then can be submitted to the Ecosystems Atlas. So rather than being just a top-down project, we actually have a role for other data coming from everywhere to come into it. And promoting this sort of mapping activity and building a picture of the world's ecosystems through local experts is really where we're going with this project. And one of the things that we've been able to develop with Google, that Google developed in consultation with sort of an understanding of the problem that we face here, is that ability of using Alpha Earth, but putting it in the hands of everyone who wants to make their own maps of ecosystems. And this is the landscape classifier, which is using the satellite embeddings that Rebecca introduced, and allowing anyone who understands the distribution of their local ecosystem types to simply say, well, this is urban and industrial ecosystem. I live here and I know where it is, and go through this process interactively. And on the fly, this Earth Engine app is making predictions of where that ecosystem occurs. This is just a quick example of this, and I'll let it run for a few more seconds. And you'll see that it will just continually build maps of ecosystems until the expert or the user is happy with their result. Then they're able to submit two things to us. One, they can submit the training data so that we can use it in more advanced models or maybe scripted models, and collect it in that global training data set. And at the same time, they can export these maps and also submit it to the GeoAtlas project. So this is an approach of taking what used to be a specialist field, which is remote sensing, the sort of thing that I used to spend, well, I still do spend hours and hours doing in my work every single day, and trying to take it out of the hands of people who are experts in that and enable everybody to start to access this type of technology and spatial modeling capacities to develop real maps of ecosystems that can be used for real conservation purposes.